Hi, my name is Kaela Fennell-Chin, and I'm part of Challenge 2014, and I'm going to be doing interactive learning number 6. And for this problem, what we're going to do is we're going to take an area bounded by this function here, the x-axis and the y-axis, and we're going to revolve all this volume around the x-axis. So how we're going to do this, first what I'm going to start off doing is trying graphing it. And since it's not our normal y equals something, I'm just going to plug in points and see what happens. So when I plug in 0 for x, we find out that y is 2. So I just plot this point right here. And I just drew a graph because it's kind of a parabola, a sideways parabola, since it's an inverse function. So now what we're going to do, since we have our function in terms of y, but they want us to revolve it around the x, we know we're going to use our shell method since these are not the same. So for our shell method, what we have is we're going to have 2 pi, the integral from a to b, which are going to be our limits, multiplied by the shell's radius, and then multiplied by the shell's height. And everything's going to be in terms of dx since our actual function had dy, since everything has y in the function. So now what we're going to do is we're just going to determine what these are in place of our functions. So our height is going to be top minus bottom. So top is going to be our function that we have right now. So it's going to be y minus 2 squared. And the bottom is just the 0. So we can put minus 0. It doesn't really affect our function right now. So then our radius, since everything in our function and that we're working with is in terms of y, we're going to have a radius in terms of y as well. And then our limits, which is going to be the limits of our integral, are going to be in terms of y. So where does our function start and end and y? So it's going to start at 0 and end at 2. So we're going to have 0 to 2. Now we're going to plug all of this into this formula that we have right here. So we're going to have 2 pi, the integral from our limits, 0 to 2 of our radius, which is y, times our height. The 0 doesn't really matter because it's going to cancel anyways. So we're going to have y minus 2 squared and then dy. So now this is the basics of what we have right now to find the volume of these bounds that we were given. And now what we can do is we can simplify this and actually take the integral. So now that we are about to simplify and take the integral, this is what we're going to have. So we're going to have this here, and we're going to FOIL it out and see what we get. So if you multiply this by this, we're going to get y squared minus 4y plus 4. Don't forget the other y, so you have to distribute this y in now. So we're going to have y to the third minus 4y squared plus 4y. Then we're going to take the integral of this, which integral is adding 1 to the exponent and dividing by that n plus 1. So we're going to have 2y, and this is going to divide by 2. This 4 just becomes a 2. Then we're going to add 1 to the 2, so you have 3y times 4 from up here, but we're going to divide by 3. Then we're going to add 1 to this 3, we get 4, and we're going to divide by the exponent plus 1, which is 4. Now once we have all of this, we're going to try to find by plugging in these two. But since if we plug in 0, everything's going to cancel out since every term has y. So all we have to do is plug in the 2. So if we plug in the 2, what we're going to get is 2 to the 4th over 4 minus 4 thirds times 2 to the third plus 2 times 2 squared. And all we did was just plug in the 2 in for every y. So now we're going to have to simplify even more. So 2 to the 4th is going to give you 16 divided by 4 minus 4 over 3 times 2 times 2 is 4, 4 is 8, plus That's to the second, so we have 2 times 4. Simplify some more. 4 minus 32 over 3 plus 8. Now we want a common denominator, so we multiply everything by 3. Then if we simplify this, we're going to get 36 over 3 minus 32 over 3, which gives you 4 over 3. And then we can't forget about this 2x that we have up here. So if we multiply this by 2x, 2 pi, I'm sorry, you get 8 pi divided by 3. And this is going to give you something around 8.378, which is your final answer. So all this together, we have that this volume revolved around x is going to give us 8.378 cubic, whatever, if it's centimeters or whatever, cubic volumes. So that's your answer for this problem. Thank you.